Hi guys, tonight I'm going to talk about tributary areas for gravity loads. We'll start with the tributary area. The equation we use to calculate total loads for horizontal surfaces like roofs and floors is the uniform load in pounds per square foot times the tributary area in square feet, which equals total uniform load in pounds. For the area, we need both the width and the length. However, these uniform loads can also be expressed as pound per linear foot, which is how we measure loads on walls and beams. To get this number, we need to identify the tributary width. When we multiply units in pounds per square feet by units in feet, we simplify by deleting the feet from the equation, and the resulting units are in feet. Measuring tributary width. Tributary width is the horizontal measure between support points. This means that the width measured is the same whether it's flat like a floor or sloped like a roof, and the slope can be a little or a lot. The tributary width stays the same. To determine tributary width for roofs, we first need to consider the type of roof structure and how it transfers its loads. The three types of roof structures are trusses, rafters with ridge board, and rafter with ridge beam. Both trusses and rafters with a ridge board transfer roof loads in the same way, so we'll look at them together. It's important to remember that the ridge board is non-structural and merely provides lateral stabilization to the rafters at their peak. To calculate tributary width for trusses and rafters, which transfer loads to exterior walls, we measure horizontally from the ridge to the edge of the roof. Note that we measure half of the roof width because half the roof transfers its loads to one support wall and the other half transfers its load to the other support wall. We include eaves in this calculation. Later we will look at eaves separately. This example has a roof that is 19 feet wide. Half the roof from ridge to eave is 9 feet 6 linear feet. The uniform load can be looked up in the building code. Let's say the live load or snow load will be 25 pounds per square foot and the dead load 15 pounds per square foot. Remember, then live plus dead equals uniform load. Our uniform load per linear foot will be our uniform load times our tributary width. Our load is 40 pounds per square foot and our width is 9 foot 6, which equals 380 pounds per linear foot on each supporting wall. Tributary width for rafters with ridge beam. Here's an example of the same house with rafters on a load-bearing ridge beam. Each rafter transfers half of its uniform load to the structurally significant ridge beam, which sits on columns or end walls, and the other half to an exterior wall. Our loads are supported by more elements in this type of structure. First, let's establish tributary width for the load on the beam. Measure horizontally from the beam to halfway to the exterior wall. Note that it's a quarter of the width from outside wall to outside wall. In this case, 1/4 of the length equals 4 feet. Measure again on the opposite side of the ridge beam to a point halfway to the exterior wall and add the two numbers to get the tributary width. Our uniform load per linear foot will be our uniform load times our tributary width. Our load is 40 pounds per square foot and our width is 8 feet, which equals 320 pounds per linear foot on the beam. Now let's establish tributary width for the load on the walls. Measure horizontally from halfway between the ridge and the wall to the exterior wall. We noticed before that it's 1/4 of the width from outside wall to outside wall, and in this case, 1/4 of the length equals 4 feet. But what about the eave overhang? What about the portion of the rafter outside of the wall? Well, we need to include it because it rests on the wall as well. So measure horizontally again from the outside wall to the edge of the rafter. Our overhang is 1'6". Add the two numbers together to get the tributary width. It's 5'6". Our uniform load per linear foot on the wall will be our uniform load times our tributary width. Our load is the same as before, 40 pounds per square foot, and our width is now 5'6". 40 pounds per square foot times 5'6" is 220 pounds per linear foot on each supporting wall. Tributary area. Let's revisit tributary area before we end our discussion on roofs. Remember the equation we used to calculate total loads for horizontal surfaces like roofs and floors? Is the uniform load in pounds per square foot times the tributary area in square feet, which equals total uniform load in pounds. For the area, we need both a tributary width and a tributary length. The example with trusses or rafters with the ridge boards has two tributary widths, therefore two tributary areas. Each area is 9'6". Tributary width multiplied by the 19 feet length for a total of 180.5 square feet. Multiply the square feet by the uniform load for a total of 7,220 pounds. This is the load of half of the roof that rests on one exterior wall. The total roof load on the small house is 14,440 pounds. This is true for both a truss roof system and a rafter with a ridge board. For the example of the rafters with the ridge beam, there are 3 tributary widths and therefore 3 tributary areas. The ridge beam's tributary width is half total span or 8 feet. The length of the roof is 19 feet. The tributary area is 104.5 square feet. The ridge load is 6,080 pounds. One wall supports 4,180 pounds, and so does the other. The combined load on this small house is once again 14,440 pounds. This is all for tonight, guys. Thank you for watching. Yeah, that's pretty much it. If you like it, like it. If you don't like it, don't like it. If you think it's really cool, share it. You know. Yeah. Bye.